just a magnificent looking animal. It's only 3 meters long. Didn't have a mark on it. Gave us an opportunity to tag her, and he placed his tag perfect.
In 2003, a shark tracking program was launched off the coast of Western Australia. The research team tagged a young great white they named Alpha, hoping to record its entire movement pattern. But just 4 months later, the tag washed ashore. When the data was downloaded, it revealed something chilling. Alpha had been swallowed whole. What kind of predator could be powerful enough to consume one of the ocean's most formidable hunters and leave no trace behind? Get ready for a deep dive into this unsettling mystery. The disappearance of Alpha. In 2003, in the waters off southern Western Australia, a research team working with the Commonwealth Scientific and Industrial Research Organization, CSIRO, and a documentary film crew began a project designed to track the survival behavior of great white sharks. The person leading the filming and assisting with data collection was Dave Riggs, a veteran ocean life documentarian with more than 2 decades of experience capturing the behavior of sharks, whales, and other apex predators. Riggs was not a scientist in the traditional academic sense, but he was an experienced field specialist who had contributed valuable observational data to many CSIRO studies. During that survey, the team approached a young female great white, about 9 feet long. She was healthy, alert, and showed the quick reactions typical of a shark in its prime years. She was no longer a juvenile, but had not yet reached massive size. The team named her Alpha and attached a satellite tag to her back. The device recorded temperature, depth, and changes in light, allowing researchers to reconstruct her movements beneath the surface. The first weeks passed without incident. The data transmitted on schedule. Alpha moved along the coastline, diving and rising in a steady rhythm that matched what is known about developing great whites. The team felt they were collecting an ideal set of observations. Then, one morning, the team received a report that the tag was no longer signaling from offshore. It had washed up on a beach only a few kilometers from where Alpha had been tagged. Tags occasionally detach early, so they retrieved it and examined the data as usual. No one expected what they were about to see. The numbers on the screen marked the beginning of one of the strangest mysteries they had ever encountered. As soon as the charts appeared, the entire team fell silent. The temperature line, which had been steady, suddenly spiked to a level seawater could never produce. Only one explanation made sense. The tag had entered the body of another creature. At the same time, the depth record showed a rapid, almost vertical dive. This was not the movement of an object sinking. It was the controlled descent of a large predator, pulling the tag inside its body. Every movement after that point differed completely from Alpha's usual patterns. For days, the tag rose and fell through shallow and mid-water depths at a relaxed pace, the kind of motion often seen in a large predator that has just fed. Everything in the data suggested that Alpha was no longer swimming on her own. She had become part of another animal's digestive tract. Eventually, the recorded temperature dropped back to the cold of the surrounding seawater. That was the clear sign that the tag had been expelled, drifting freely until it washed ashore. When the data was assembled into a full timeline, the story pointed in one direction. Alpha had been ambushed, swallowed whole, and dragged downward by a creature far larger and more powerful than she was. The trail of a giant hunter in the dark. Alpha's disappearance left a troubling question. What could have taken down a healthy great white in the prime of its life so quickly? The team began comparing the tag's data with known predator behaviors in the waters off Western Australia. They immediately realized the attacker could not have been a random animal. Every movement recorded after Alpha vanished had the precision of a practiced hunter, something familiar with dominating deep, shadowed waters. The first possibility considered was another great white, significantly larger than Alpha. Cannibalism is not unusual among sharks. In many regions, dominant individuals maintain territories, and smaller sharks that stray too close may be attacked without warning. Larger sharks possess the size, jaw strength, and acceleration needed to end a confrontation in a single strike from below or behind. When the team compared Alpha's timeline with older records, they noticed that the steep downward dive after her disappearance matched the behavior of a satiated great white. Large individuals often dive deep after feeding to stabilize their temperature and rest, then rise again to patrol shallower waters. The tag's recorded rhythm aligned with that pattern in a striking way. Other surveys had also documented unusually large great whites living permanently in deep canyons, where sunlight barely reaches the floor. These places function as personal territories for oversized individuals. If Alpha swam into such a territory, a sudden ambush would have been almost inevitable. With this context, the idea of a giant great white became the most reasonable explanation. Alpha was strong, but small compared to the largest sharks patrolling Western Australia's offshore environments. A single surprise attack in deep water could have ended everything before she had a chance to react. As the team explored the data further, another potential suspect had to be considered, a predator so formidable that even adult great whites avoided it: the killer whale. Orcas are among the most coordinated hunters in the ocean. They hunt in groups, use complex strategies, and have been documented killing adult great whites in minutes. If anything could overpower Alpha instantly and drag her downward, an orca would seem like an ideal candidate. At first, the idea seemed plausible. Orcas can approach silently from depth and flip or drag a shark with remarkable force. A small group of orcas can clear an entire region of great whites in a matter of hours. But the tag data did not match orca behavior. The movement after Alpha vanished was too steady and too slow. Orcas move erratically after a kill. Their depth patterns shift constantly as they feed or regroup. The tag's descent and subsequent rhythm looked like the work of a solitary animal, not a coordinated pod. The way orcas consume sharks also conflicted with the evidence. They target the liver, tearing the body apart rather than swallowing large sections whole. A tag passing intact into an orca's stomach for days on end did not fit any known pattern. There was another issue. No environmental signs indicated orca presence. With decades of field experience, Dave Riggs knew the disruptions orcas create. Birds behave differently, fish scatter, and underwater acoustics change. None of those clues appeared during Alpha's disappearance. The orca hypothesis faded, leaving a clearer picture. The predator was not a group. It was an individual, extraordinarily large, fast, and efficient enough to turn a 3-meter great white into prey within moments. This forced the team to confront a more unsettling possibility. The attacker might have been a rare oversized shark, a predator far beyond the average size for its species, the kind scientists hear about only through fragments of data and stories from the deep. When the hypotheses fell apart under the data. After ruling out the orca, the research team continued to examine every other theory that had circulated around Bremer Canyon. This was a region known for its extreme depth, strong currents, and the occasional appearance of animals that rarely come close to the surface. When Alpha's data became public, some people suggested the attacker might belong to an entirely different species, perhaps even something modern science had never properly documented. The first idea to surface was the colossal squid, a deep-dwelling giant with hooked tentacles and eyes large enough to see through near total darkness. Some individuals were believed to reach lengths of more than 10 meters, more than enough to stage an ambush in the canyon. With that strength, a colossal squid could, in theory, drag a shark downward before it had time to react. But when this idea was placed beside the tag data, it no longer made sense. Squid are cold-blooded animals. Their body temperature always matches the surrounding water. The tag, however, showed temperatures far warmer than the seawater after Alpha disappeared. Numbers like that could not come from a creature that lacked the ability to generate its own heat. No matter how intimidating colossal squid may be, they could not have been responsible. The second theory spread faster than any other, the reappearance of the megalodon. The name surfaces whenever an event occurs in the ocean that seems to exceed modern understanding. A massive predator living at great depth feeding on whales, and large enough to swallow alpha whole sounded like a tempting explanation. But a theory can survive only when there is evidence to support it. In this case, there was none. No new teeth, no fresh bite marks on whales, no modern data that matched the characteristics of a prehistoric giant. Even more telling, the behavior of the creature that swallowed alpha did not resemble what a massive animal would need in order to survive. It did not travel far, did not perform repeated deep dives, and maintained a very steady movement pattern for days in shallow water. That was inconsistent with the energy demands and movement patterns of an enormous predator. The second theory spread faster than any other: the reappearance of the megalodon. The name surfaces whenever an event occurs in the ocean that seems to exceed modern understanding. A massive predator living at great depth, feeding on whales, and large enough to swallow alpha whole sounded like a tempting explanation. But a theory can survive only when there is evidence to support it. In this case, there was none. No new teeth, no fresh bite marks on whales, no modern data that matched the characteristics of a prehistoric giant. Even more telling, the behavior of the creature that swallowed alpha did not resemble what a massive animal would need in order to survive. It did not travel far, did not perform repeated deep dives, and maintained a very steady movement pattern for days in shallow water. That was inconsistent with the energy demands and movement patterns of an enormous predator. Once both colossal squid and megalodon were eliminated, the team returned to what the data had quietly suggested from the beginning. The attacker was a real animal living in today's ecosystem, not a monster from legend. What made the case unsettling was the fact that an animal considered top of the food chain had been taken down so easily. And it was at this moment that the picture became clearer. The dives, the temperature changes, and the gentle movements recorded after alpha vanished all matched the behavior of an oversized adult great white. A shark far larger than alpha, living alone, operating at depth, and strong enough to execute a perfect ambush in seconds. The team was no longer searching for a mythical creature. They were facing a type of individual that science knows exists, but rarely observes directly: the oversized super individuals of the great white population. Larger, thicker-bodied, more experienced, and far more dangerous than their ordinary counterparts. As these fringe theories faded, one question became impossible to ignore. The creature that swallowed alpha was not merely big. It was a true outlier, an individual powerful enough to impose its own rules in the twilight zone of the deep ocean. The real predator emerges. Alpha's case was not a random accident, nor was it linked to any legendary beast. It was the result of a very real attack, carried out in mere moments by an animal large enough to erase all trace of a 3-meter shark with a single strike. The temperature data was the first and strongest clue. The tag did not enter just any body. It rested inside a warm, stable environment for many days. That warmth matched the internal heating ability of adult great whites, a trait that helps them digest food quickly and hunt efficiently in cold waters. As soon as alpha disappeared, the temperature rose sharply and stayed elevated. This is exactly what happens when a large predator is digesting a substantial meal. Next was the sudden deep dive. The animal that swallowed alpha plunged downward immediately after the attack, then slowly returned to shallower water. This was the familiar pattern of a large great white after feeding. They descend to cool their bodies or avoid competition, then rise again to patrol. Every detail of the depth record matched this behavior. It was smooth, rhythmic, and lacked the chaos of a prolonged struggle. The most important clue appeared in the tag's movement during the days that followed. If the attacker had been a pod of orcas, the movement would have been erratic. Orcas change direction constantly as they hunt or regroup. If the attacker had been a giant squid or any deep-sea creature, the temperature would never have remained so warm. Instead, the tag moved with slow, steady patterns, the signature of a solitary large animal unaffected by the dynamics of a group. When all the pieces were placed together, the conclusion became undeniable. The creature that consumed Alpha was not simply another great white, it was a giant individual, the kind that scientists hear about through rare tagging incidents or unusual patterns recorded by deep-sea sensors. Based on the data, this individual was likely at least twice Alpha's size. With that scale, an attack from below that ended the encounter in seconds was entirely possible. If it had lived for years in a shadowed region like Bremer Canyon, its ability to ambush would have been even more formidable. Individuals like this are the true apex of the ocean hierarchy, seldom seen, living deep and dangerously efficient against any smaller shark. What made the case particularly chilling was the silence of the ocean during the attack. There was no commotion, no chase, no warning. Alpha simply vanished from the survey in a single moment. In the days that followed, the tag traced the calm routine of a predator that had finished its meal and returned to normal life. The event revealed something most people never consider. Great whites may dominate many areas, but in deep places like Bremer Canyon, there are individuals even larger, older, and more ruthless. They do not appear near the surface often and leave almost no trace, yet they remain there, quietly ruling the twilight zone of the deep. This realization led the team to their final question, the one that opens the door to the next chapter. If such an individual could make Alpha disappear in seconds, what kind of hierarchy is operating in the depths below? A hierarchy that humans have barely begun to glimpse? The power structure of the deep ocean. When the team finally pieced together Alpha's data, they realized the tag had revealed far more than the disappearance of a young great white shark. It was a quiet but sharp reminder that the ocean does not operate the way people imagine. The bright waters where research vessels routinely travel represent only the surface, a thin layer where species cross paths for brief moments before vanishing again. Beneath that blue light lies another world, a hierarchy that humans rarely witness, and Alpha had simply wandered into the edge of it. Decades of collected data show that in places like Bremer Canyon, dominance does not belong to numbers, but to individual animals. These oversized great whites live in isolation for years. They grow far beyond the average size and seem to know every current, every crevice, and every shadow where sunlight almost never reaches. They do not chase noisily or create dramatic scenes. A single ambush is enough to decide the fate of any smaller shark. Creatures like these do not follow the patterns found in textbooks. They do not migrate along predictable routes, rarely appear near shore, and spend most of their lives almost invisible. They occupy the dim regions where sunlight fades, where slow currents roll through deep rock channels, and where every movement can determine whether they live or die. In that depth, sound does not travel far, injuries remain unseen, and encounters end too quickly for any camera to capture. Alpha's case was simply one of the rare moments when a human-made device happened to fall into the very center of such an ambush. A brief instant in which the deep ocean's hierarchy revealed itself. Looking back at the data, the researchers understood they had not observed the behavior of a single predator, but the actions of a force that had always existed, yet had never been clearly identified. The deeper they dug into similar disappearances from the past, the clearer it became that this was not an isolated event. Tags had gone silent without warning. Individual sharks had vanished without a trace. Deep and unusual dive patterns had appeared in archived data. All these fragments pointed toward a common source, one hidden in a region so dark that even sonar cannot fully map it. This reality led many researchers to ask difficult questions. How much does humanity truly know about the ocean's deeper layers? How many of these enormous individuals exist? And more importantly, what kind of evolutionary pressure shaped them into predators strong enough to overpower a healthy great white like Alpha before it had any chance to react? There were no immediate answers. The ocean did not offer explanations, nor did it allow easier access. But Alpha's case opened a narrow doorway, revealing a glimpse of the true order within the deep, a place where the strongest predators live by their own rules, quietly, without display, and without mercy. That silence is what makes the ocean truly frightening. Not because of creatures we have not yet discovered, but because of the ones we know exist, the ones that leave almost no evidence for science to study. Alpha was simply the first victim whose story was recorded from inside the predator itself, before the tag was expelled and washed ashore. What the team uncovered did not close the mystery. Instead, it opened an entire realm of darkness that scientists will have to confront in the years ahead. A realm that does not belong to imagination, but lies directly beneath our feet, deeper, wider, and older than any ecological model ever built. Alpha's case was only the introduction.